Equation of the normal to the tangent. A tangent to a curve is the line shown over here in blue that touches the curve at a given point, and a normal to the curve is the line shown in red that meets the tangent at 90 degrees. We would like to find the equation of the normal line to the tangent at a point P with the coordinate x1, y1. First, we need to find the slope or the gradient of the tangent at x is equal to x1. And to do that, we require the first derivative. So we find the first derivative of the given function and evaluate the first derivative at x is equal to x1. In other words, we replace the x in the expression by the x1 coordinate. That will give us the gradient of the tangent, and using that we can calculate the gradient of the normal, which has a relationship as -1 divided by the gradient of the tangent. Hence the equation of the normal would be y minus y1, that comes from here, is equal to mn, which is the gradient of the normal, into x minus x1. Or alternatively, we can write y minus f of x1. If you're only given the x coordinate, we can find the y coordinate by evaluating function f of x at x is equal to x1 is equal to -1 over f dash of x1 into x minus x1. Let's see an example. Find the equation of the normal to the tangent to the curve xy is equal to 10 at 2, 5. The first impression of this expression would give you that you would want to apply implicit differentiation, but instead I prefer to make y the subject of the formula wherever possible. So I could rewrite this expression as y is equal to 10 over x, or equivalently 10x to the power -1. This is much easier to differentiate, by the way. So the derivative, applying the power rule, multiply that -1 to 10, we get -10, reduce this power by -1, we get x to the power -2. Now we evaluate this derivative at x is equal to 2 to find the gradient of the tangent, and that happens to be -5 over 2. So all we do is replace x in the derivative function by the x1 value, 2, and evaluate, we get -5 and 2. Then we find the gradient of the normal using the relationship -1 over the gradient of the tangent that we calculated up here. So that is -1 over -5 on 2, and that gives us 2 over 5. Now we use the general equation, starting with the form y minus y1 equals mn, the gradient of the normal, into x minus x1. It is important that you write this expression so that you don't make a mistake. Then we replace, or we substitute the known values. For instance, x1 and y1 are known. Likewise, mn is known, so we replace those by the known values and make y the subject of the formula. We end up getting 2/5 of x plus 21 over 5. That is the equation of the normal to the tangent at the point 2, 5 in the graph on the curve xy is equal to 10.